Hi, I'm Susan Teeters. I'm Program Director at the Tulsa Glass Blowing School, and I'm here with Karen Draper, who is our lamp worker, and we're going to be talking about lamp working today. Lamp working is an old technique on how to work with glass in a softened, almost molten state, using a torch, which is what you can see is in front of Karen right now. Instead of being in front of a molten pot of glass where we have to gather with metal pipes, this is another way to work on a very small scale to make beads, sculptures, all manner of things. If you look right here at the front of the table, these are some of the examples of things that can be made. There's some sculptures there, there's certainly a lot of beads. Marbles are made this way. That's how they were originally made, is using a torch and rods of glass, which you can see Karen is working with here. So you can see that the flame kind of changes color when she puts the rod of glass in there. That's not just because the glass is getting soft, it's because of the chemical nature of the glass. So because of the metal components in glass, what we call metal when you're a chemist, sodium or boron change color in a flame, and it's a test for those two metals.
Additionally, the metals and minerals are also how we get color in glass. And so one of my favorites actually is silver nitrate. And it does this cool thing. You can see this rod started out clear, and then as you strike it in the glass and in the flame, it will actually change colors, and it brings the silver forward. And as that silver develops, it gives you the different colors. So color work in glass is actually more chemistry than color theory, unlike painting. A little bit of color theory, but a lot of it's chemistry, which makes it kind of a challenge sometimes, and you get some surprises sometimes, and makes it really fun.
So what Karen is talking about when she says striking is there's always oxygen in these torches, and that is what the chemical reaction is stimulated by, is that oxidation or reduction environment that we talk about as chemists to get these different colors. Some colors are much more expensive than others because of the metal that they contain. Some of the colors contain gold, and those are usually the colors that we like the best, like reds and pinks. Have lots of gold in them, just like that. Makes a nice, beautiful color, which I think surprises people because when you think about gold, you think it's just going to be yellow. But really, in its other states, it can be red. Now then, Karen has other things available to her to work with besides just rods, right? You have frit.
Frit, which the frit is in front of me, and it's basically just ground up glass. And it can be different sizes. It can be fairly large, or it can be as fine as a powder, depending on what effect you want with it. And so what that does is it captures, if I use a clear, that'll capture some of those metals in there. So as I develop the color around it, it'll have different colors in it, and we'll let it develop differently and give you a little more interest in your piece.
The other thing about color, which is really complicated when you're talking about glass, because we're really talking about inorganic chemistry with reactions between inorganic metal salts, is that you can have color reactions within a piece. And what that means, if I can just point it out here, this bead right here, you can see it's kind of like these turquoise dots in there, but it looks like there's a brown ring around them. It's called a color reaction. So the chemistry of that blue, that turquoise color is reacting with the other chemicals beside it. And so it's at that boundary, it's setting in another color. The other thing is that the chemistry of this glass is not the same as we work with molten glass. Molten glass is called a soda lime glass. It's also known as soft glass. It doesn't have anything, it's not talking about its properties, it's just the way it is. It melts at a lower temperature. What Karen is working with though is called a borosilicate glass. And most people know that from, if you've taken any kind of lab classes, all lab glassware is made from borosilicate glass because it has excellent thermal properties. You can put hot water in it, pour that out, and all of a sudden put ice in it and it won't crack. So this is an example of what borosilicate glass looks like versus a soft glass. And can you see the difference? No. So we can't really tell. And the reason we can't tell is just it's not obvious to our eye. So if we were to try and mix these, we couldn't get a successful piece. because borosilicate and this soft glass, or the soda lime glass, expand and contract when they're heated at different rates. So the borosilicate doesn't expand and contract very much. It doesn't move very much at all. Where the soft glass, it really expands and contracts really well, which is why we can't take this, heat it, and then put it in ice without it shattering. So if this is moving, contracting, and expanding a lot, and it's pulling against something that doesn't want to move very much, you get a lot of strain, and then they break. So what Karen is working with is boro glass with boro glass. But we're going to show you here pretty quick what happens. Yeah, if we try and mix boro glass with soft glass.
And the other thing about soft glass is you get more of a shock when you put it in the flame. So you'll notice with the boro, I just stick it in there. With the soft glass, you got to warm it up a little bit, or you are sharing hot glass with everybody across the room.
So because it has that thermal shock, it doesn't have very good thermal properties at all.
Yeah, it doesn't like to be heated and cooled quickly, where boro doesn't really. And you can see how much faster the soft glass melts compared to the boro. It just kind of hangs in there. So what I'll do, and I never want a piece of soft glass with my boro. This is really unusual, so that's why you see me setting it away. Because if you spend an hour working on a sculpture or a piece and you accidentally pick up a wrong rod of glass, you just ruined your whole piece. And so what we'll do is kind of let this cool off. I'll let you hold that. Let's put the fiber blanket under it. And as that cools, what you're going to see is the boro is going to stay a little bit stiffer, where the soft glass is going to try to shrink up a lot faster. And so the boro is a lot stronger, so it shatters the soft glass as it tries to shrink up.
So if you were able to look at it, and I know you can't see it quite as well as we can, but there's already cracks that are starting to develop in this little piece of glass that she's worked with.
Can you get it against my black shirt?
And then it
Kind of, sort of.
so as it gets cooler and cooler, it's just going to actually break.
It'll break. And so that's why you never mix glasses.
All right, so that's a quickie overview of lamp working. Come see us at the Glass Blowing School if you want to see more, and stay tuned for more great STEM videos.
Thank you.